All right, today we're going to talk about Chapter 18, Perspective. Drawings. Okay, when we talk about perspective drawings, we're going to talk about drawings that you see every day as your eye would see them. Chapter 18 covers drawing types, oblique drawings, isometric drawings, axonometric drawings, and perspective drawings. So starting out with the drawing types: oblique, isometric, and perspective. Oblique is just like it sounds. If you look in your textbook on the Chapter 18 on page 660, you will find that an oblique drawing looks something similar to this. Notice your X and your Y. Okay, basically your X is at a 90 degrees. Your X and Y both vertical and horizontal, but your Z is what makes the oblique. Oblique drawings, they're either a convenient 30 or 45 degrees. Circles appear a true shape in the front and as ellipses in the rear. So if we're looking at a front view, of a part that has a hole in it, for instance, and has a hole. But if I'm going 45 degrees and it's on the side view, then it's going to be an elliptical shape. Now you might be asking yourself, how do I do this in AutoCAD? Well, let's look. Let's bring up AutoCAD. Now, first of all, what we need to do in AutoCAD is to set our snap. And set our snap in grid so we can actually draw in 3D or in the isometric perspective. So just right click, go to settings, go to your first snapping grid. Right here under snap type, we want to go to ISO and hit OK. You'll notice that your cursor changes. What we have here is a Y and Z axis. Now to change our cursor, all we have to do is hit the F5. Now what do we have? We actually have a Z and a Y axis. Now we have an X, okay, and a Z. So if I was to draw isometrically, make sure your ortho is on. Notice that this is set at 30 degrees. Now is this an oblique? Remember that an oblique is either 30, according to your book on page 660, oblique is either 30 or 45. Now to change my directions, I go to F5 to make my vertical. Go ahead and make my other 30-degree line, and then I close. Okay, now I have a side view. We'll come back to AutoCAD. Let's talk a little bit more about the different types of oblique drawings. Here's the oblique. Again, 30 to 45 degrees on your Z-axis. Your next is isometric. This is the most common pictorial. So if you have most of your drawings, when you're a design drafter, most of your drawings are going to be done using orthographic projection with your top view, front view, right side view. Okay? But next, what you most commonly find nowadays in the upper right hand corner, you're going to have a isometric view. Okay? So again, here's your top. There's your front and right side. And this is the ISO. Most commonly, this is how your drawings are going to be set up. The angles in an isometric are 120 degrees from each other. Circles appear as ellipses in all the views. Do not show hidden lines. This is crucial. Do not show hidden lines. We'll talk a little bit more about how to do the circles in an ellipse fashion in AutoCAD when we get through some more of the PowerPoint. All right, here's just some isometrics. Notice that you have the basic shape. We have a basic shape here. Okay. Here's your 30-degree angles. Except for this one. Notice that this one's not at 30 degrees. That's called a non-isometric line. And of course, it's not at true length. Okay? Another thing I want you to notice, that your x-axis or your y-axis is just basically straight up. All of these are at what? 120. Simply put, that's the common denominator with an isometric. There's the actual projection right there. Okay? Notice it has that Y shape. All right. Isometric drawings. Offset measurements are used to locate one feature in relationship to the other. So what command are we going to use in AutoCAD to get our measurements? The offset command. Non-isometric lines are not parallel, are perpendicular. Remember, parallel are perpendicular to any of the three principal views in a multi-view drawing. All right, here is a multi-view. You notice that your points A, B, and C. This is given right here. Irregular shapes are drawn, dividing them into series of convenient sections or a layout grid. Irregular shapes are drawn by dividing them into a series of convenient sections or layout grid. Use a template for circles and arcs. So you notice that we have 7 points that we drew here for our arc. Even spaces parallel to the base. Where's the base? Well, the base is right here, and everything is parallel to it. Okay? Now, we're not going to have to worry about this drawing. In my CAD-112 class, we are doing everything in AutoCAD. So this would be if you were drawing it with the swing points for your compass if you're doing the board drafting. Anammetrics, that includes projection, Dimensions along three principal edges are foreshortened. Exploded drawings show all the components in assembly as an individual isometric drawing. And then assembly drawing shows how a single product looks when assembled. Pretty simple. All right, here are some different axonometric drawings types. They're diametric and trimetric. Don't use them much. The trimetric you have available to you when you guys get in parametrics as an option. Axes are rotated so that each angle is different and scales are also different. All right, now remember these. These are going to be on your test. A cavalier. The receding lines are at 30 degrees and drawn at full size. So, let's think about this. Same as a cavalier, but receding lines on the cabinet. And a general oblique is similar to a cabinet drawing, except the drafter may choose any scale. Now, with these three types of axonometric, what you want to do, let me pull up. Let me pull up a drawing here from your book. That actually shows how you do your cabinet. On page 18, actually, on page 672 is actually a good example of how to do your cavalier, your cabinet. You notice that everything on there is drawn to full scale, and your front view is drawn as a front view. Okay, you notice that the front view is the front view. It doesn't change, and there's a reversed on that one. Here's a cavalier. Again, the only thing that's different is the angles in which they recede. Cavalier, the receding lines are at 30 degrees. A cabinet's the same as a cavalier, but the receding lines are only half size. And then the general oblique is similar to a cabinet, except the drafter may choose any scale. All right, so what you want to do, for instance, let's look at an example of what I would do. So if I have a shape that's, say, something like that. With an isometric, we would go what? Like this, and draw it. But with the cavalier, cabinet, or oblique, what we're going to do, we're going to draw a front view just like it is. And then these lines right here are what makes a cavalier and a cabinet. Now with the cavalier drawn at 45 degrees, and with the cabinet, a cabinet is drawn with half size. So you would just break it in two because they're basically both the same, except the receding lines are half. Okay? So this is a cavalier, which you can find on page 673 of your text. This is a cabinet. 30 degrees minimum, 60 degree max, half size, full size. Your front view is drawn at full size. Remember that. It's going to be on the test. Okay, perspective. I've got a nice video. Guys, perspective, a 3D drawing that shows visible lines almost as a person's eye would perceive from a particular location. Here's some terminology. Station point, ground line, horizontal line. Measuring, you'll notice that you have a picture plane, the PP, and you have a station point where everything's viewed from. Let's watch a nice video real quick of perspectives.
We're going to draw some perspective. We're going to draw a road and some phone poles and building going into the distance with some mountains and shadows and all that kind of stuff. We're going to do it really fast. You can't do perspective without a horizon that you're looking into the distance at. And so that is our distant horizon. It could be the ocean, it could be anything, but in this case it's just where your eye level is. And we're going to put 2 points. These will be our vanishing points. How about one there and one there? It doesn't really matter. You'll see what they do later. Or actually, you'll see what they do right now. This is our road going into the distance. You know that classic V shape? We've all probably done this. You know, with the lines, and they get shorter and smaller as they go into the distance. So now I'm going to draw a reference line to along which we're going to run our phone poles. They're going to go right along this road. Matter of fact, let's shade in that road so we can actually see what we're doing. So there's a road, asphalt, black road. We need to have a reference line for the top of the phone poles too. Here will be the bottom and this will be the top. So what we'll do is we'll draw one pole in here in the front, and there you have rounded bottoms and all that little stuff sticking out of them like this, right, to climb on. And we'll just draw one cross brace like this. We're not going to spend a lot of time drawing a bunch. So what we need now is to put another one next to it. Now it's going to be bound by the rules of this point. Everything has to go to that point. So we'll draw another one between that point and that point on the line. Be a little thinner. There's a whole math to figuring out how to make things, space things as they recede into the background, but you can just fake it. Just make them look good. You can draw lines between these 2 points so that these are all identical. There are lots of little things you can do. So we'll just keep going here, and so on, and so on. And we'll just make these go like that. So there we have our phone poles. We'll put some telegraph wire on them. We'll make that one disappear out of the drawing. So there are the phone poles. Now what we're going to do is come over here and we're going to put a house on this. Maybe we'll make this a sidewalk. So this is the edge of the sidewalk, and here are your sidewalk concrete poured things, whatever they're called, sections. And maybe we'll draw a little walkway going from here to the house. So we know our house, we want it to be right about there, the front of it. So we'll just draw a point right past that. This is just a reference line I'm drawing. Maybe we'll make this house about this wide. How's that sound? Right about that wide. Where do we want that roof to be? We want it to be a 2-story house? Do we want to go high on it? Or do we want to go low? I think we want to go about there. That's our reference point for the house. So our house is going to all happen right in front of our house, at least, is going to happen right in that space right there. Everything going on in the house that's facing that direction is going to all be bound by the rules of this point. So what I like to do is just sort of, just put a bunch of lines, just sort of, to just get a good idea of where.
All right, guys, you notice that everything is going to a vanishing point. Okay, that's where you come to understand what perspective is. It all goes to a vanishing point. We had a horizon line, all right, which if you look in your book on close to the last pages, all right, on page 676 and 677, Notice you have a horizon. Now, this is 1-point perspective because everything is going to one vanishing point. Now, we're also going to do in this class a 2-point perspective, which you'll have then what? You'll have a left vanishing point and a right vanishing point. Okay? So, this drawing is bound by the rule of the one vanishing point, which makes it a one perspective.
You know, what I want to put on this thing. It just, oops, I just realized I had a little walkway there. So that's our front door right there. And the top of the door would go, actually it falls right on the horizon line. This is the top of our door heading toward that point though. And if we were to put a window in the door, these top and bottom of that window would also follow the directions right to that point. And this is a window. We're just going to plug in here. We'll put a thinner window right here. And the bottom goes to the point and the top goes to the point. We can put in, you know, a little side action there so that it looks a little thicker. We'll reseat that door in there and make that look really nice. Now what we're going to do is we're going to put a side on the house. You know what, this is a little point. This point's a little close to the house. You'll see what I mean. So I'm going to move that point over here. And what I'm going to do is have all of this side of the house point to that point. So that gives us the side of this building. It's a coincidence I'm drawing that through that point. It's no bearing at all. So now we've got this is the side of our house. And we could put another window. As a matter of fact, if we continue this on here and take this point and run it to the point, then we'll get the exact same depth on our windows. So we could put a couple of windows here. That would be just something like that. We could split them in the middle. The bottom of these sills would go that direction. You can see how that would work. This actually goes over there. This one would come here, straight up like that. So there we have those windows. Even that we could even split these in two. These lines are a little crooked because I'm drawing a little sideways. Now if we wanted to put a roof on this thing, just draw up from the middle. Maybe the roof's about that high. Why not? We'll go from that point to there, that point to there. Now this edge of the roof will go to the point, to the vanishing point over here. This edge of the roof will also go to that vanishing point. And yes, so will the top of the roof go right to that one point. This is a simple 2-point perspective.
Okay, this is a 2-point perspective. Which means what? We have two vanishing points.
When they have the sun right about here, well, these phone poles are a little light, you can't really see them.
Okay, let's talk a little bit about how we're going to do this in AutoCAD. Okay? So let's pull up AutoCAD. We've kind of already started one, but say we want to do a cavalier. All right, do you remember what a cavalier is? A cavalier on page 673. Remember, the front view is going to be full scale, regular front view, and then the receding lines on a cavalier is also full scale. The difference between a cabinet and a cavalier is that a cabinet is half size. Okay? So let's just let's take a simple part. Let's take it out of. Let's go back to the rectangle for a second. Make sure our ortho's on. Let's start at 0, 0, enter. We're going to go over 3 inches, enter. Let's go up 6 inches, enter. We go over 0.75, enter. Come down 2.0, enter. Go over 0.75, enter. Go up 2, enter. Go over 0.75, enter. Go down to enter. We're getting pretty close to the end. I think I have 0.75 left. Then I can come down and snap. Okay, so we got a front view. Now, for a Cavalier, again, what's a Cavalier? Cavalier is true size in the front and then full size in the rear. Now, what on page 373, we can actually do a 30 to a 60 degree for a Cavalier. So let's go to our choices. Let's go to settings. You'll notice that on the isometric, I can control angles on the polar, the grid snap. We're going to use this. We can actually go to this angle if we wanted to change it to 45. Hit OK. You notice that now my cursor has changed from a 30 to a 45. So let's go L, enter. Let's put an edge. Looks like we're still at 30. Okay, we're going to leave it go at 30. So let's put an edge. We're going to, this thing is 6 inches deep. All right, we're going to go up. Where were we? Got to be full size, right? So we were what? I think we were 5 inches tall. No, we weren't. Let's go L. Let's go 6 here. 6 here. Come back to that point. Okay? Now what else do we need? Well, everything's got to go back to one point, right? So we're going to measure that line. Put that line in. We're going to have one here too, right? What about hidden lines? Do we put hidden lines in? No, we don't. So what do? We have to trim this line. Like so. Let's go ahead and bring the rest of our lines back. Up. Do we show that as hidden? No, we don't. We trim it. Okay. Now what about this? We still got a back corner at the top. What do? We can hit F5 and change our angle and go L, enter. Now we got to make sure that everything is extended to that line. Boom, boom, boom. Now let's trim this out. There we have it. What is that? Okay. Looks like to me that we've got something wrong in the rear. Or do we? Does it look like these lines here are parallel? To be parallel, what do? Well, we're going to have to take it off of our grid. And let's go back to our rectangle. And start here and go straight over. Now let's do some trimming. All right? Get rid of that one. I'm going to do a fillet. Now what do we have? What do we have? We have a Cavalier because it's a regular front view and a full size. Now how do we make it? How do we make it a cabinet? Well, what do? Well, we make an offset. We know that our depth was at 6, so we just want to offset 3. How do we do that? We go like so. Or we can take, because that's not going to be the true shape, is it? Let's go back to our settings. And let's change this back to isometric. Hit OK. Let's go L. Start there, and we're going to go 3, enter. And then up. And of course, do all the trimming from there. Okay? That is what? That is your cabinet. And then your general drawing, basically any appropriate scale between half and full is correct. So this could be a general also, but we designed it as a cabinet. Okay, let's look at our assignments for today on chapter 18. All right, for our pictorial drawings, if you guys want to watch you ever want to watch the PowerPoints, they're right in here. Okay, you can watch them yourself. I also have these images that are in the book. They're also in the assignment handout. Let's see, I think actually they're... I thought they were in teaching aids. All right, there's your instructions. Here's your assignments. I want you to do 18.1 in the book. Let's look at 18.1 really quick here. 18.1, construct an isometric drawing of the objects in problems 18.1 through... These problems have straight lines only. So we're not even dealing with any curved shapes at this point. They're all straight lines. We're going to do 18 through 8, 9, 10. Looks like I'm going to skip 14, 15, 11, 12, 13, and 14. And we're going to do 15 and 16. I also have... I want us to do some of the 1852. We're going to talk a little bit about exploded isometric drawings and the assembly of the vise. And I also have some 1- and 2-point perspectives that are not on here. We're going to do these kind of outside of class. Okay? All right. So let's get started in our perspective drawings. This is Mr. Johnson, CAD-112. Let's get her done.